Hello viewers and my dear students. Welcome to session 3 on problem 3 on analysis of beams. Here I will be showing you a demo on simply supported beam with partially applied UDL, that is uniformly distributed transverse load using Ansys Release 14 of Mechanical APDL exclusively to obtain bending stress and deformation diagrams. This is very important. To obtain bending stress and deformation diagrams, it's very difficult to get the information there. You have to stick to the procedure carefully. You see here, now the problem is the same problem. Okay, as you know here, we have already, this is the problem, we have for this, we already found out bending moment and shear force diagrams and all that. Okay, now we concentrate on bending stress. Bending stress, as you know here, maximum bending stress is m into y by I, where we take maximum bending moment. Maximum bending moment was 42,670. We have done in the last session. That you apply, and depth 0.3 by 2. You don't get confused. Depth should be more. Okay. 0.3 by 2. 0.2 into 0.3 cube by 12. This, if you simplify, it is 0.148 into 10 to the power of 8 Newton per meter square, or 14.8 into 10 to the power of 6 Newton per meter square, or 14.8 megapascals. Maximum deformation from the plot will be 0.00162 meters. This anyway it has to be verified. This is very important thing, and you have a separate procedure which you have to remember and do carefully. Okay, see here we have done already list log file done already. Okay, list log file, there is nothing. This is only the title of the beam I have given, beam analysis partially applied UDL, applying that is bending stress diagram. We'll concentrate only on bending stress diagram. You know how to get bending moment and shear force diagram. This is maximum bending stress diagram, where you can find maximum bending stress also. This is very important. Preferences, structural you go, just say okay. Okay, then preprocessor, element type you go, add, edit, delete you go, add, beam 2 node 188 only you take, just say okay. Just say close. Then at the real constant, don't worry, material properties you go, material models you go, structural, linear, elastic, isotropic, it is 210 E9. Okay, that is 2.111. That is Newton per meter square. This is the thing. And 0.27 is the Poisson's ratio. Okay, and this is 210 into 10 to the power of 9 Newton per meter square. That means the modeling and all that I have to do it in meters only. Okay, just say material exit you do. Okay, then section you take, beam you take, common sections you take, same way you do. Rectangular section 0.2, 0.3 you take, just say okay, same way as the previous one. Okay, 0.2 and 0.3 you take, common sections and all that. Now modeling you go, create key points in active coordinate system. 1 you take, 0, 0, 0, correct now? Apply you take, then 2 you do, it is 4, 0, 0, apply, 3, 6, 0, 0, apply, then 4, this is very important, 4, 6, let us say minus 1, it is just only for changing the orientation. This point is very important. Just say okay. Now I got this 0, 0, 0, this is 4, 0, 0, 6, 0, 0, and 6 minus 1. In that way I got the coordinate. You can even check list key points. If you go, you get the same thing, 0, 0, 0, 4, 0, 0, 6, 0, 0, 6 minus 1, 0, and all that you get. Anyway, this is the thing what you know. Okay, now once you do this, create lines, straight line, you click on this 1 to 2 and 2 to 3 also you click. Okay, just say okay. Now I'm doing the modeling part. Then meshing very important, you see here. Meshing, orientation has to be changed. I'll show you how exactly the orientation has to be changed and all that. Mesh attributes you go, picket lines, click on this, just say okay. and compulsorily pick orientation key point, you make it yes. Okay, this is a very important thing. There is only one material, okay, and beam 188, there are no multiple materials. Here pick orientation key point, you make it yes. Just say okay and click on this point. This is the orientation point. If you do this, the beam gets shifted by 90 degree, that is rotated by 90 degree, you will know now. Okay, this you say, just say okay. Okay, then size controls you go, lines, that is size controls, manual size, lines, picket lines, you make this, you click on this also, just say okay. Number of divisions, as in the previous problem, you make it 50, you make it 50, just say okay. That means 50 and 50 elements you got. Okay, once you get this, then mesh, lines, you either do pick all or click on both the lines. Just say okay. That means if you see list elements, if you get 100 elements, you would have got. This you have to check. Otherwise, if you have not created elements, you won't get the answers. Okay. Plot, multiplot. Okay. Now you see here. Now plot controls. Now you see style, size and shape. If you see display elements on, you do. Say okay. Okay. Display element on, you do. Then you say okay. See here, beautifully we got. This is 0.2, this is 0.3. If you zoom the model, you know. Okay, this is 0.2, this is 0.3. You have to load it parallel to Y. Okay, parallel to Y. This is that thing. Okay, I'll just fit it. Okay, parallel to Y. I should load on this. Okay, I should load on this. Okay, now what you do? You know, anyway, this I told you. This is 0.2, this is 0.3. The orientation is proper. And on this surface, on the top surface, you should load. That is UDL only up to this 40. Okay, up to 4 meters. Okay, then what I'll do? Plot controls, style, size and shape. This I'll remove it off. Okay, I'll go to the front view. Plot elements. You go in the same way. Plot elements and all that you do. Now it is that. It is, we have completed up to that. Now we will go for loads, define loads, apply, structural, displacement, on key points, click the first key point, click the last key point, see here, say okay, and UX, UI, UZ, rotation X, rotation Y, you make it 0. Okay, this is as usual we done. And now you see here, now pressure on beams has to be applied, no? As usual, as I've done in the last time, you have to be very careful here. Now what I'll do first, plot controls, numbering, element numbers, I'll make it on. Otherwise, we'll not know what exactly is happening here. Okay, element numbers, I'll make it on. Now pressure on beams you take. Now you take first box. First you take box, you apply whatever, because you have some confusions here. You take up to, say, only up to 50 elements. Other than 50 is for the other section where you don't have UDL. UDL is only for up to 50. Okay, 50 element. You just see. Okay, then go for single. Okay, first you enlarge. Where you have gone, you know. Okay, 49 you have gone. Okay, 50 also you do. Okay, once you go 50, 51, 52 and all that, you see 51, 52 and all that, you don't need. Okay, you cancel it off. Up to 50 you have gone. Okay, as you see here, up to 50, 51 is this. You see 51, 52. These are all wider. These are all small ones. That's why you should immediately know that you should stop at 50 only. Okay, now you have stopped at 50. Be careful, you have to select only up to 50 elements. That is 4 meters only. 50, 51 and up to 100 is 2 meters only. It's all small length elements. Okay, be careful about that. Then we'll say fit view. Okay, I've applied. Then say okay. Lower key, don't change it to 2 like the previous problem. Let it be 1 only. Then compulsorily minus you give. Minus 12,000. Minus 12,000. minus 12,000 you give. Okay, just say okay. Now you are perfectly doing this. Okay, and now I'll show you in the 3D also. Plot controls, style, size and shape, display element on. Just say okay. 3D, plot controls, numbering, no element numbers and all that I don't want. Okay, I'll just say okay. Now you see here perfectly it is UDL has been applied to a distance of 4, and as you see here this is very important. Okay, this is 0.2, this is 0.3. Okay, this is 0.2 and this is 0.2, 0.3, and the UDL has been applied downwards up to 4 meters, partially applied UDL. Now it is proper. Now what you are doing is in the proper direction. It is all correct. Then you go for the front view. Okay, now everything is proper. That is plot controls, style, size and shape, display element off you can do. Just say okay. Okay, plot, multiplot you do. Okay, now everything is over. Or plot elements also you do. Okay, this is perfect way. Now this and this have been arrested. Everything is done correctly. Now we'll go for the solution. Solution, solve, current LS you do. Just say okay. Okay, then once you do this, okay, see carefully. Once you do this, in the general post process, I've told you, first thing what you do is deform shape, deform plus undeformed. Now perfect way of getting 0.001626 is the thing what you got already. That is 0.001626 is the thing what you should get, that you got already. That is this exact maximum deformation here, 0.001626. In the same way, you do this element table also you go, define table, add by sequence number, SMISC 34 you take, apply, SMISC by sequence number 39 you go, 34 and 39 you take, 34 and 39 will give you the bending stress diagram. Okay, you just say close. Okay, now you plot results. You go for plot results, contour plot, line element results, 34 and 39 you select and just say okay, and you should get bending stress diagram which you have to copy and show it to the examiner. Okay, this is the perfect way. You see here 0.142 e to the power of 8 is the answer. Maximum bending stress is 0.142 into 10 to the power of 8 Newton per meter square, or 14.2 megapascals. This you have got it anyway using theoretically 14.148 10 to the power of 8 Newton per meter square. Okay, exactly. This is matching with the theoretical results. In that way, you see here, this you have got it clearly. Now, as I've said here, this is in this deform shape, deform plus undeformed, this plot controls, write meta file, invert white and black, this image you have it, and show it to the exam. Maximum deformation is 0.100127162. In the same way, plot results, line element results, 34 and 39, this also take plot controls, write meta file, invert white and black. In that way, this is also another very important result what you should show it to the examiner. Okay, once you do this, okay, you see here all you know already, list log file, you know, list log file, you have this, the entire thing you copy. Okay, the entire thing you copy, and if you want, wherever you want, you can make changes. Okay, and here you paste it and you get the new result. Okay, you can change the load or whatever you want. You can come out of this file, clear, start new, fresh screen. Copy the file. The file is important. That log file is important. You copy and paste, you get it. In that way, even this complex problem with partially applied uniform distributed, partially applied UDL, we are completed. We are in the session 1 and 2 covered bending moment and shear force diagram. In this bending stress diagram also. Thank you, friends. Thank you for watching. Thank you.